one of the ways that you can achieve it is through the use of what's called TEE. And this is what OASIS focuses on. So first of all, TEE is an acronym, stands for Trusted Execution Environment. Okay, but what does that mean? Well, it's pretty complicated, actually. So we can look at this paper called Intel SGX Explained, and we can say, all right, well, there's all this research that goes into it, and let me do a deep dive. Maybe I'll have ChatGPT summarize it for me and have their deep research do it. That's one approach, but realistically, in this short time I have here, that's not the best way to explain it. So we need to simplify. But if you are curious, you can read about it right here. Okay, so let's just have one simple diagram, perhaps. So a TEE, we have this non-secure world of computing, and we have this secure world of computing. We see the TEE is on the right here, and it has the secure world. And by secure, we have some sort of trusted applications, trusted operating system, and they're all stemming from this protected hardware resource. It's still a little vague, but we can see, okay, this is going to be some sort of hardware level security. If you want to get even less specific, but maybe a little easier to visualize, we could just think about it as a black box for computation. This is the way I like to explain it to people. If you're not super technical and you're not worried about the inner workings of TEEs and you just want to use them, this tends to be the best way to explain it, at least at first. So it's as a black box, we just take some input. This might be some data that you want to keep private, some computations, a smart contract, what have you. It could even be a centralized system. But we put it in this black box and we get some output at the end, and we don't see what happens in between. And that's basically the simplest way to think about it. And the key here, though, is that this technology, this black box, is using hardware level isolation. So that means it's either running in the CPU or in a GPU. And the way that the CPU or GPU does this is through what are called attestation mechanisms. And these basically provide the verifiability. So by verifiability, we mean that we want to be able to confirm that even if we can't see what's happening, we know it is obeying a certain set of rules. It is obeying the rules that are defined somewhere else and that are agreed upon in some sort of perhaps global way by multiple parties. And therefore, verifiability is kind of one of the key aspects of blockchains. People talk about transparency as being important, but perhaps even more important than the transparency itself is the verifiability that comes with that. So that's really what we want to focus on here. Okay, so we dealt with crypto and we addressed privacy. So how can we combine the two now? And we can do that actually, well, maybe not so easily, but we have done it and it does work. So by combining these trusted execution environments with a blockchain, you can have this black box situation again. You take your encrypted data, you have some smart contract, it does some computation, and you get an encrypted result. And this is very nice because a lot of smart contract applications today, essentially all of them, are fully transparent, and that limits what you can do with them in general. Most Web 2 applications, let's say just on some website, for example, it might be your bank account or it might be a messaging app, they have a degree of privacy. It may not be absolute total privacy from all parties, but it does have some sort of level of access controls or hiding of information from certain people. On public blockchain, you can't really get that at all. And some people might find that desirable. We think that that severely limits the usability of apps themselves. And therefore, in order to increase the usability even more, we decided that it would be smart to build not just a blockchain, but an EVM blockchain. And so we did that, and it's called OASIS Sapphire. So Sapphire is the first and only confidential EVM blockchain in production. Many people are also working on various EVM strategies with blockchains, but this was basically the first, and we are still basically building an ecosystem out of that. And basically the way it works under the hood is that you have this network of nodes, and it's running Intel SGX, which is this technology I explained very briefly earlier. This is basically a bunch of nodes that all have the same kind of hardware, And by performing computation together, they can come to consensus in a confidential manner. So what you get out of that is that transactions, call data, and even smart contract data itself can all be encrypted by default. Okay, I just said that this increases the usability, but what are some on-chain use cases that we can actually get out of this? Well, in the case of DeFi, which is probably the most useful overall use case of blockchains at the moment, at least so far from what we've seen, what if we just directly added confidentiality with no kind of distinguishing features? Well, we would get private swaps, which is really nice because one, I don't want people to see all my financial data, so that's a bonus. But two, with private swaps, you can also get automatic MEV resistance, which if you're not familiar, MEV is basically the way that validators can extract value out of your trades by deciding on the ordering of them. And so if they can't see what is inside those trades, there's no way to financially benefit from deciding on the order, and therefore there's no MEV. The second way is through, for example, with loans. So think of a lending protocol like Aave, where you have perhaps some collateral and you take out a loan against that collateral. Well, there is a certain price that that collateral can reach where you will get what is called liquidated, meaning that that collateral will be sold off in order to pay off your debt because it is no longer equal to the value of the debt that you've taken out. And typically these protocols are over collateralized so that they don't have bad debt. But all this to say that there is a point where you basically lose out. You don't want to get liquidated. It's a bad thing. And so what people have figured out over time is for certain assets, under certain conditions, you can actually target people and manipulate the price of an asset in order to liquidate someone and profit from that process. But if you hide the liquidation threshold, well, that's a lot more difficult now, isn't it? So this is another benefit that we could see confidential DeFi might be able to offer. Another overall overarching use case would be DAOs. We see a lot of value in any type of DAO that exists. It should have some degree of confidentiality, perhaps not entirely, but if we want these systems to mimic real world systems that we've already built, like elections, basically every Western nation, to my knowledge, implements private elections. I don't think any results are public as far as I can tell. And so it is natural that we would want this ability to have on-chain confidential voting as well. And we actually built this ourselves because we think it's important. And we called it Block Vote. And basically you can go here to vote.oasis.io and check it out for yourself. But I'll get into this more in a moment with some more details. The third overarching category I'll talk about is kind of the other category. It's hard to kind of group these together, but things like on-chain access controls for off-chain applications, which ties into decentralized key management. These things are a little more nebulous. They do require a bit more explanation, but they are very valuable in providing a broad range of applications, the ability to have basically increased security, increased decentralization while maintaining privacy. Let's talk about Block Vote for a second though. So it's a very simple website. We basically built this where you can create a poll, and when you do that, you'll get all these options. You can, of course, ask questions and get responses. But the real importance here is that these responses are going to be weighted in some way based on-chain metrics. So it is, in essence, meant for DAOs to vote on. So it can do token snapshot voting. It can do it based on NFT contract addresses or ERC20 tokens. You can adjust the weighting based on one person, one vote, or I guess one wallet, one vote, to be specific. Or it could be linear with the amount of ERC20 tokens or some other function. And this is also multi-chain, meaning if you are on Ethereum or Arbitrum or something like that, and you want to maintain your users on the host chain, but at the same time have a confidential vote, you don't have to move all of your users to a new chain, which is really infeasible for most people. And finally, we also gave this the option to be gas-free, meaning there's even less friction because you can have users on other chains basically just sign transactions without spending the gas token on the Oasis network, ROSE. And as the creator of the poll, you can basically subsidize all of their votes up front. And typically the cost is pretty small, and this is not an issue. So it's generally recommended to do this. Okay, so that was one specific. So we talked about DeFi, we talked about DAOs, we talked about, I didn't update this slide. I didn't actually talk about gaming, but that's another interesting one. Basically, if you have any on-chain game and you want to make the game more interesting, having a riddle or a puzzle is a nice idea. So you can't do that on a transparent blockchain. Ideally, you'd like to be able to keep some secrets because that secrets make things interesting, make things fun. So with Oasis, you could do that. But yeah, sorry, I didn't update the slide. However, there's one thing I have not talked about yet, right, basically during this whole presentation, and that is AI. So let's talk about AI. First, we'll start with just AI in general. What do we mean by it, right? It's been this hot topic for almost 3 years now. Obviously, it's existed much longer than this. What do we mean by AI? Right now, many people find this controversial, but typically we mean that it's a large language model. And this is something like chatbots, it could be ChatGPT and Claude. This might be, or even DeepSeek, right? The competitors are definitely coming to the fold. Open source, we always like open source. It could be image generation though, it could be video generation, like Midjourney. So there's all sorts of ways that we can have AI and we can have large language models. And so I don't want to conflate the two, that they're the exact same thing, but they've definitely shown that they're very useful to people and they're worth talking about and they're worth building on. So is there a way perhaps to combine the nice decentralized benefits of blockchains and this privacy and verifiability? Can we combine that somehow with AI? Well, let's say we just took an LLM like DeepSeek, right? We could run it open source and what if we just took it and stuck it on a blockchain? How would that work? Well, these LLMs, typically, if you want to run them at scale and efficiently and fast, they require GPUs. They also definitely require GPUs for training, but even for inference, which is producing an output, you're going to want a GPU generally. There are ways that you can use a CPU, and for certain use cases, that's okay. Yeah, that is one hurdle. Maybe not an impossible hurdle, but it is one hurdle. With blockchains, they are all run on CPUs. The second thing is that their outputs are non-deterministic. If you give the same input to an LLM, you're not going to get the same output every time. So if you just have a network of nodes that are just replicating some computation, it is not trivial to just say, well, aggregate the result for all of them and average it out or something, because blockchains want to be very deterministic. They want to come to consensus and make sure everyone agrees on exactly what has happened. And this process, as a result, is also very compute intensive. And that does not blend well with LLMs, which themselves are compute intensives in the first place. The third issue that we run into is that blockchains can't access the web. And this is by design, because the web is also not deterministic. Things change over time. So if I say, hey, the result at this API is such and such, well, that might change, second to second even. So if two nodes disagree about a result, that might just it might just stem from the fact that one node queried an API a millisecond after the other node and something had changed. So we just avoid the whole issue by having blockchains not able to access the web. Unless you have some sort of trusted oracle who can handle this delicate process of medianizing and aggregating non-deterministic results. But this is by no means an easy thing to do. So yeah, so basically there's three issues that we run into. So overall, on-chain AI is actually very difficult. And so yeah, you might say, okay, let's pump the brakes a bit and see if there's maybe something else we can do. So what if we just combine privacy with AI first and not worry about the blockchain part? And we just run everything off-chain for the time being, right? Well, you can definitely do that. There are centralized cloud providers, and they offer the use of TEEs. So, this is feasible. You have Google Cloud, you have Microsoft Azure. So, okay, we can do this today, cool. But it begs the question, can we trust these providers? If we're running everything in a centralized way, one, you're trusting them for liveness, but you're also trusting them for things like censorship, resistance, and various other aspects. And if you really do trust them, which that's fine if you do, well then why even use blockchains at all? What are we doing here? Why are we talking about them? So this would kind of lead me to the conclusion that the fact that people care about blockchain so much means we probably can't trust these providers. This might be some circular logic, but bear with me, I think it'll all make sense. So a lot of it stems back to this idea of verifiability. I mentioned this briefly near the start, but let's talk about it a little bit more. Let's think of a more concrete example. Like, let's say I'm using some LLM and I am, paying a lot of money for this API access and I'm using it for my business or something like that. How do I know that I'm receiving outputs from the model that I actually paid for? I just have to trust that this is the model that they say it is. And if the results are really good, I'm going to be happy and say, all right, it must have been the one that they said. And if the results are bad, I might say, hey, this doesn't seem right. I think you're maybe cheating me. But it's not really a strong way of knowing. Another thing is, how do I know my data is being handled appropriately? There are toggle buttons that you can click to say, hey, don't share my data, don't train on my data, keep it private, don't remember my sessions, one session to the next, don't keep a persistent memory of my behaviors and my preferences. You can ask them to do this, but again, you're just trusting that these providers will actually do it. And with the amount of data breaches we've seen, that's not really, I'm not a betting man, but I would not bet on that either. So and the third question is, how do you ensure liveness? Of course, every website has had outages at times. No website has 100% perfect liveness. So we want to have some robustness to this, and ideally have some sort of backups. And here is just a screenshot of ChatGPT. This was 3-4 months ago or something like that. I took it. They've had pretty good liveness, but it's not 100%. So these are things we do care about, though. Like, let's say I did have a business, and this business was reliant on ChatGPT or on OpenAI's APIs. Well, if I was centrally relying on them, I might have problems with my customers now, and that's really not good. Maybe that's my fault as a businessman for not, centralizing across multiple providers or something. But if I do my due diligence and I decentralize, well, we're going right back to the importance of decentralization and not trusting a single provider. So it's all tied together. And on the topic of, am I getting what I paid for? You can visualize it very easily. Let's say we're comparing GPT 4.5, which is now already outdated. I made this slide weeks ago. And Microsoft 5.4, which is a very small model, a very inexpensive model. Well, they're about a 1,000x difference in cost. So if I'm paying for the one on the left, I want to not be getting the one on the right, because that would really be unfortunate for me. I would be wasting my money and getting inferior results and inferior product. And again, there's no real way with these centralized providers to ensure I'm actually getting what I paid for. So of course, I'm here today to say, is there a solution? Yes, there is a solution. And I will explain exactly how that happens. Basically, this is not so basic, but the most basic way I could describe it in an accurate technical way is that we're combining off-chain computation. We are going to run it in a TEE, which is what I explained earlier. And we're going to use that remote attestation process that TEEs give you. And then if we post that publicly on-chain, we can get scalability, we can get confidentiality, and we can get verifiability. And I color-coded this just to make it a little clearer what aspects are giving you what features. So if it's off-chain, it's more scalable. If it's TEE, it gives you confidentiality. And TEEs themselves use remote attestations, which is what makes them able to be verifiable in their computation. And so this is the way we can unify these three concepts of privacy, crypto, and AI. And more specifically, in order to implement this, we have been building, and at Oasis, we have this product called ROFL. And it does not stand for rolling on the floor laughing, as the emoji here might indicate, but it stands for runtime off-chain logic. And very simply, it allows developers to create policies, and then they could anchor these policies on-chain. And then, so that's the developer side. And then from the hardware operator side, you have these kind of two parties with their interests in mind. The node operators can run specific binaries, and this might be some Docker image, for example, and they can remotely attest that, yes, I am running the correct software that you've provided me because these builds can be reproduced and they match, and therefore they can do things like acting as a trusted oracle. An oracle, in a very general sense, is just something that's acting off-chain but interacting on-chain, and so that's kind of the definition we're using here. And then in addition, we can have arbitrary software that runs in these containers. This is powered by Intel TDX. As a side note here, TDX itself is built off of SGX. So I would not confuse the two, but they are definitely related and they do sound similar. So that is intentional. So TDX is CPU based, but we can also do things now like LLM inference and training. And since this runs on the GPU, well, we need a GPU that has hardware level support for this. Fortunately, NVIDIA actually built a GPU stack that supports this natively out of the box. So the NVIDIA H100 does support confidential compute. It essentially runs its own TEE, and you don't really have to do much more work than that. You have to build kind of the software around it, but the hardware itself supports it, which is great. Because otherwise, building your own GPU is definitely extremely difficult and expensive. This is a diagram just kind of explaining, kind of connecting the dots of how ROFL fits together with everything. I don't want to frame it as some nebulous off-chain world. It's pretty concrete that you basically are just running something off-chain. It is periodically interacting with a blockchain in order to attest, and also in order to do things like trigger on-chain transactions or post data on-chain. So in that sense, it can act directly as an oracle. And then on the flip side of things, you can also do things like external queries. You can query APIs, which I guess is over here. You can run light clients for other blockchains in order to observe transactions that are happening on those chains and relay them. This is what we call a bridge. So it can do all of the things that have been built over the years, and it does them in a centralized way, but at the same time, it does them in a verifiable way. And that is the point I really want to keep hammering home here, that yes, it's centralized. In principle, you can start to kind of decentralize things, but there's always trade-offs. But by having that verifiability, you can at least trust that you're not going to be cheated. I think that's something that people really will value today. So with all this being said, okay, so we have this off-chain system. It's verifiable. It can do private confidential compute. That's great. But if we're going to go back to the off-chain, like the example with Google and Azure before I was talking about, if we're going to go back to off-chain, then why do we care about the blockchain in the first place? Why would I use Oasis Sapphire, which is the confidential EVM, if I can just do this off-chain? Well, there's certain things that you do actually want to keep on-chain. We're not going to move everything back on-chain. For example, payments and execution logic still need to be handled on-chain because these have persistent storage, and also they enable users to self-custody their funds. So let's say we ran some banking system entirely within a ROFL application, and it's on one node, and that node goes down, and the server catches fire. Well, your money's now gone, right? So we still want to decentralize certain things. Having users self-custody their funds on a blockchain, which is globally distributed, that's a really nice thing. We've figured out over the last 15 years that people like that a lot. It's really popular, so we're going to stick with that. But other things we do want to keep centralized. So in practice, it's going to be a mix. It's going to be these decentralized rails that we can keep our applications on, and then have the applications themselves be a little more flexible in certain parts. And that gives you, better features. So you could think of it as like maybe people being able to build their own businesses, and those businesses are more centralized, but the system that those businesses run on top of are more decentralized. This is one way that, in my view, so-called dApps have been operating largely. It varies, of course, but for example, if you have a dApp with upgradable smart contracts, you as the contract owner, if assuming there's no DAO in place, you basically have a centralized smart contract. But at the same time, if users want to pull their funds out, and they do that, then they are once again in control of their funds in a decentralized way. So there will be times where it's centralized, but times where it's decentralized, and being able to flexibly combine the two is, I think, really powerful. So at the end of it, you get these confidential smart contracts, you get off-chain TEEs, and when you combine them, you get this full end-to-end encryption for any application. So this is all a little bit hand-wavy. Hopefully you're still following, but let's talk about a very specific example. Today, there's tons of AI agent projects out there, and they're all purporting to do similar things. Maybe some are different, but there's a lot of competition in the AI agent space. And I think not because it's just hype, I think because there is real value there. Having an ecosystem of intelligence, essentially, maybe not people, maybe we're not at AGI yet, but having this ecosystem of some sort of intelligence doing things for you without your input is extremely valuable. I think it'll be a multiplier on human productivity overall. So I can see why there's a lot of hype around it. So imagine that we have this autonomous AI agent, and it's running off-chain in a Raffle application. And at the same time, it's managing some on-chain wallet, some funds, maybe some Ethereum or something, USDC or whatever. Well, if it's running off-chain on a centralized server, then it begs the question, who controls the private keys? Because while the funds on-chain are on a decentralized blockchain, if only one person has control of the private keys, then it's just centralized control of that money. And at some point, you're kind of begging the question of what are we doing here? Well, one way you can kind of improve on this is to say that if we have, let's say, Oasis Sapphire, you have this on-chain decentralized persistent storage of data that can go inside of smart contracts. And so you can do things like having a decentralized key manager, and that lets you facilitate access controls. And so basically, instead of just having one centralized server, you now have this way that many servers are securely storing that private key without revealing it to the world. If you tried to use, let's say, Ethereum as the access control and keep, store your private key on Ethereum, well, it is no longer a private key; it is now everyone's key, and you will lose your money. So this is really only something that can be done on a confidential ledger. So also, though, you could do things like storing message history confidentially. This gets into more specifics of kind of application that you want to build, but this is still useful, and it has actually been done by us. So our team built this Raffle demo starter, and right now it's just on testnet. But you can go to this link, playground.oasis.io, and check it out. I also have the URL here. If you just search chatbot, it'll come up, and you can check out all the code in the GitHub and everything. And there's information in the GitHub about exactly how everything is done in terms of securely processing data and things like that. But what it does is it basically anchors a query on chain, on Sapphire. It keeps it confidential, and then this chatbot can fetch that data, run some encrypted results, and then give you the result back. So my slides are a little messed up. That's okay. All right, so my next slide is when Raffle, because this is a question people are always asking about. Well, initially it supported Intel SGX, and it is now on mainnet for that. And now, in addition to that, well, first of all, SGX required apps to be written in Rust, which is fine for certain people, but it did kind of limit the usability and the, I guess, diversity of apps that can be built. People want to build all sorts of applications, and Python, JavaScript, etc. And so for that, you actually require Intel TDX, which is now supported. And so basically, you can package everything up in a container, and this is available on mainnet now. While it does give you greater flexibility, it's not necessarily something that everyone should do, because Intel TDX actually does require a much larger trusted computing base. What that means is a potential larger attack surface. We do try to keep security as a massive focus for us. So, any possible attack vectors that we try to think about it, but no software is perfect. I think it's healthy to have that mindset that there will be bugs, there will be security vulnerabilities and things like that. So trying to minimize that as much as possible, for example, by using SGX instead of TDX, is one way to accomplish that. something to keep in mind. The next step will be to build a Raffle marketplace. So right now, yes, it's on mainnet, but if you want to run an application, you need to provide your own hardware or find someone to do it. And for most people, that's not going to be really feasible. There's a lot of friction involved there, and having a Telegram chat be the main way that decentralized applications are launched doesn't really make a lot of sense. So we want to build a marketplace for this where we can bring hardware operators that have these trusted execution environments, bring them together with app developers. So you can just say, hey, I built this, I want to run it in the cloud essentially, and I'll pay such and such dollars per month, and here you go, and they'll run it. That's the next step. And then the next step after that will be support for NVIDIA GPUs, because we want to support applications that are not just in the CPU, but things that are more compute intensive, like LLM queries. I know I did say that we have this chatbot, this demo starter. This is actually running in a CPU though, and it is quite slow. So that's why it's just a demo. Ideally, things like this would be running in a GPU for production-ready use cases. But that is still to come. So if you want to learn more about Raffle, I included the links to the docs here. You can also just Google Oasis Raffle. It'll be the first thing that comes up. But yeah, overall, there's one more thing. So the next thing to think about is, well, okay, we have this system. It's technically on mainnet. We have this demo, but what else can we build with it? Are there people actually building on this? And I can't tell you everything that's being built, but one of the things that was recently announced in early April is this grant award for Tamarin. And basically, they're going to be using Raffle and Oasis TEs for healthcare data privacy. And I think healthcare is something that is really worth mentioning, because there's so much data out there, and being able to compute on, and due to regulations, it's really difficult to share this in a proper way and keep it secure. But there is a lot of value to be unlocked by computing on healthcare data. I think for diagnosis, for drug discovery, cures, things like that. So I am personally looking forward to seeing what this kind of technology can do for the world, in a very idealistic way, I guess. But it does excite me. So yeah, very happy for Tamarin here. Okay, that is all I have to say. So thank you very much. I've included a bunch of links here. So we have our socials. This is the Oasis official. This is me. We have our Discord. We have our Telegram. If you want to join any of these communities. We also have an ambassador program. If you want to get involved in terms of just learning more about Oasis, connecting projects together. For example, we have a business development ambassador, subspecialty kind of thing. If maybe writing Twitter threads is more your thing, or blog posts, there's many ways to be an ambassador. So any talent that you have, anything that you're passionate about, I'm sure you can find a place, and we'd love to have you. We also have a grants program. If you're a builder or developer looking to build maybe a confidential smart contract or some sort of verifiable compute system, please get in touch with us. If you submit a grant application, it'll go straight to me. And we also have a university program, which is probably not too surprising considering the audience I'm talking to. But yeah, you can check out the link here. So yeah, anyway, that's all. I really appreciate everyone's time, and I'm happy to take any questions. And otherwise, yeah, that's it.
Yeah, awesome. Thank you so much, Robert. I think that was super helpful, and I definitely think we learned a lot there. I guess we can open it up to audience questions too. I know I had some questions prepared for you as well, just to be ready. So if anyone has any questions they want to ask now, please go ahead, and then I can ask some as well too.
I have a question.
Yeah, sure, go ahead.
Hey, Robert. Thank you for the presentation. I was in a bit late, so I just wanted to ask, as far as building goes, this is just more of a general question. How do you guys continue to sustain yourself and continue on building when, things haven't been the best in the market? And how do you just keep morale up within the company?
Yeah, I mean, in terms of financials, I can't really give specifics. I don't know too much about it anyway, but I think we're healthy there regardless. In terms of morale, it is tough. As someone, I am personally, aligned with Oasis and Rose and everything. So yeah, it's not fun. Bear markets or whatever you want to call this, it's not fun. But At the same time, you can't really say like, I look at like, okay, let's say tariffs are implemented, like, okay, and stock market prices went down because of that. Like, what does that have to do with what we're building? It's, we're still building the technology. We still believe in it. The data is still private. Like the tech is still there. So at the end of the day, you just have to say, look, we believe in this vision and we see it as a long-term vision and we want to stick with it. And yeah, that just keeps me going. So it actually doesn't really work for me all that much.
Okay, thank you.
Yeah, I think one question I had too was, in terms of like you were saying, for like grants and like encouraging development, using Oasis, I guess definitely a lot of our members are interested, in working on projects or like testing out ideas they have. And so I guess in terms of like you were saying with the actual grants and like working with students and also developers, maybe if you could touch a little more on like how that process works and like what it entails also just for anyone that might be interested.
Yeah, sure. So the grants program basically is tailored towards people that want to bring applications to mainnet and support them over a period of at least a year, I would say. So it is meant to kind of have a incentivize a more long-term ecosystem vision. So we do try to incentivize people in various ways, like hackathons. In contrast, it's just build this thing very quickly, try it out on testnet, come up with cool ideas, and the rewards typically are much smaller because of that. The grant program is a much more collaborative thing in mind. So we'll basically, we can have a meeting if anyone's here is interested. You can have a meeting one-on-one with me, and basically we can talk about what you're looking to build, any ideas I have, where I see the two kind of fitting together. And then, basically develop a plan for how that could be implemented, build it, and we can help you with things like marketing and, any development advice that you need. We can work hand in hand with you as well. So it's a much slower process than a hackathon, but it's definitely something we really do like to focus on because we want that sustained development and something that will actually drive usage.
Yeah, awesome. Thank you so much. And then I guess in terms of like, this is kind of more like a general question too, as well. In terms of like the actual, like development of the ecosystem, I guess, could you maybe touch a little bit more on like when, Oasis kind of first started and like how the development process has been like, and I guess, what it took to kind of get to this point?
Yeah, sure. That's a great question. So Oasis has been around for quite a while. The original research that went into, I guess, what we would call Sapphire now, was called Ekadin. And that paper was written or published in 2018 with some co-authors like Dawn Song and Ari Jules, which was stemming out of the IC3 Alliance, which is more of an academic kind of crypto-focused alliance. So that was the impetus, and then from there, Oasis became a project. It did a raise in I think 2020. Launched the blockchain, and then from there it was it came down to actually building all of this privacy infrastructure, which was not easy. Like originally we had a transparent EVM. There were lessons to learn from that, and then that transitioned into this confidential EVM, Sapphire. So that's been on mainnet now for about 2 years, I would say. And yeah, that's been our main focus ever since because it's such a unique thing, and it's so, I would say, so powerful. So Sapphire has definitely taken a lot of our focus, but in the last year or so, we've seen also, well, maybe a little more than a year at this point, but we've seen the importance of AI into everyday users' lives. And so, of course, there's kind of an AI hype, an AI boom, whatever you want to call it. But it's also important to recognize like people do want to build things, and so we should support builders. And so Raffle is basically the response to that, in order to kind of seamless on and off chain components together. So yeah, that was kind of our roadmap and how we kind of evolved over time.
Awesome. Yeah, thank you so much. Let's see. So Lucky, you said, do you guys have any other further questions too? I think one kind of final question, I guess, I was kind of thinking about was I know I saw you mentioned the stuff about AI agents as well, and I think that was like a really big thing that I was kind of surprised to see it like ETH Denver this year. A lot of focus on that. And I know, like you said, there's definitely like a lot of hype in this space, but there's also a lot of good things that are being built. And I guess I was just curious, like I know, like you said, you can't sometimes always get into specifics, but I guess I was just kind of curious what like interest you've seen for like AI agent development using Oasis and like what kind of support you guys have for that too, and like I guess what you guys see the like future roadmap is concerning things like AI agents.
Yeah, I think maybe one specific way I see them being very valuable is with being able to analyze our data, like our individual data, and do something for us in regards to that. So to be specific, like let's say, I have tons and tons of chats in Discord, less so in Telegram, but there's tons of data to learn about me as a person from that. It would be cool if I could have a personal agent or assistant or whatever you want to call it. What if it took all of that data from all of my chat histories over the years and made a copy of me and could make decisions for me? It would be interesting to see, would that make good decisions? Would it be accurate to things that I would do? And if it is, then you're basically multiplying your productivity. Like I was saying earlier, you basically have this assistant that can read your mind more or less, or at least based on your past decisions. So, but of course, I would not take all of this, let's say all this Discord chat history or something. I would not want to take that and upload that into the cloud because that might have a lot of sensitive and personal details. So how do you do this in a secure, confidential way? Well, TEs are probably the main way we're going to do that. So in terms of agents, that's to me like something that's super powerful. It's like, what if I have an agent that can, like book plane tickets for me or whatever else, but it knows my preferences. It knows like, oh man, I hate the middle seat, stuff like that, where I don't have to tell it over and over. I don't have to go into Manus or one of these other agent type apps and say like, hey, here's a 2-paragraph explanation of what I want you to do for me. And, because by the time I type that out, I could have just done it myself maybe. So that's maybe a very specific, but that's where I see things kind of in the future.
Yeah, awesome. Thank you very much. If anyone else has any questions, definitely feel free to hop in now and just ask. Let's see here. Let me just make sure no one else wants to. But yeah, I think that was a really valuable event for all of us. And I think this definitely provides a lot of value for our members. I know it's always great to see, especially for people who are like newer to the blockchain space, see a lot of the interesting projects being worked on, and a lot of, like you were saying, a lot of the technological innovation that's really important. So we really appreciate you guys helping us organize this and taking the time to do the event with us.
Yeah, absolutely. Our pleasure. Very happy to be able to have outreach like this. So yeah, I appreciate everyone's time.
Yeah, absolutely. And just, I guess, maybe if you guys could send me like the contact, all the info you showed as well too. That way I can send that out to any members that weren't able to make it. And that way, if they want to check anything out or like learn more about Oasis, they can do that as well.
Yeah, that would be perfect. I'll send it in Telegram.
Awesome. Yeah, thank you so much. That sounds great. And thanks again. We really appreciate you guys for helping put this together.
All right, perfect. Thanks, Max.
Thank you. Have a good one.
You too.
Recording stopped.